Right, so we'll be discussing paper 3 now for this video. Right, so for paper 3, for this video, we'll be discuss the October-November 2023 paper 3-1. Okay, so let's start with question number 1. Right, so they want us to find the exact value. So highlight the keyword exact. Your final answer should be in fraction, all right? It shouldn't be in a long decimal number, okay? And then for the curve, okay, which the gradient of the tangent is equals to 8. So the word gradient of tangent basically tell us that it is dy dx equals to 8. Right, then from here, from this information, we want to find the coordinate for the points. Right, so we'll start first. Okay, first of all, we are having the curve equation. This is the equation of the curve. Right, and then to find out the dy dx, of course, we need to go through the differentiation. Okay, so what's the formula for differentiation here? Generally, for this question, I'm having the u over v pattern. So y equals to u over v. Therefore, for differentiation, I would like to use the quotient rule. So the general formula for the quotient rule will be v squared. Then you copy the bottom, differentiate the top, minus copy the top, differentiate the bottom. Okay, so basically this formula is provided in the formula booklet. So if you can't remember, you can refer to the formula booklet provided, right? Okay, so I will start with the differentiation here. Okay, so what do I have here is, I want to square the denominator where I'm having 1 minus 3x squared. Okay, then copy the v. V is the denominator, so I copy 1 minus 3x. Multiply with du dx, that means multiply the differentiation of the top, the numerator, so I'm having 2x. Minus, now I copy the top, which is copy the numerator, differentiate the denominator. So I'm referring to the original denominator here. It is 1 minus 3x. So differentiate, you have negative 3. Okay, so this is how we go through the differentiation by using the quotient rule. And after that, they say that dy dx equals to 8. Therefore, I will let dy dx equals to 8. And then I try to solve this equation. So what am I going to do now is I'm trying to expand everything that I have here. Okay, then divided by 1 minus 6x, then plus 9x squared. Okay, then I'm trying to get the x coordinate first. So to get the x coordinate, try to solve this equation. Oh, there's a careless mistake here. It should be negative 3x squared. Alright, then you try to expand the bracket, everything, and group all the terms at one side. Okay, so if we didn't do any careless mistake, right, by right, we'll get this quadratic equation here in terms of x. Alright, so I will try to factorize it. So you need to do a little bit of trial and error, right? If not, then maybe you can use calculator to help you, or maybe you can use quadratic formula to help you to get the value of x. So after a little bit of trial and error, I realized that I can factorize this equation, where it can be 5x minus 2 multiplied with 15x minus 4. Right, then I will get two values from x. So x is having the value of 2 over 5, and also x is having the value of 4 over 15. So these are the two points, right? The two x coordinate for the points that is having a gradient of tangent equals to 8. For this question, they're asking for the exact coordinates. That means I also need to continue to find the value for the y, the exact coordinates for the y. Therefore, when you are having the first point, x equals to 2 over 5, what's the value of y that we get? So the value of y that we get will be, you substitute the x value into the equation. So 2 over 5 squared, which is the x squared, divided by 1 minus 3x. So 3 multiplied with 2 over 5. Okay, so if you didn't do any careless mistake when pressing calculator, the answer should be negative 4 over 5 for the y. And then when I'm having the x equals to 4 over 15, okay, so same thing applies here. You try to substitute the value of x into the coordinate of the y. Okay, and again, if you don't do any careless mistake, right, by right, you are having a fraction which is 16 over 45. Okay, so for the answer here, for these two coordinates, right, we'll keep the answer in the fraction form. As the question already mentioned that they want to have exact coordinates. So for exact coordinates means that I'm not going to change it become long decimal number. I will just keep it as fraction form. Especially the second part here, the second x and y here. 4 over 15 and also 16 over 45, we just keep it as fraction. So this is how we actually answer question number 1. Okay, then now we come to question number 2. On an Argand diagram, they want us to shade the region where the point represent a complex number z satisfying these two inequality. Right, so let's have a look for the first inequality first. Before I want to sketch the locus, okay, on the Argand diagram, what am I going to do is, I'm trying to put it in the form of z minus a complex number smaller equals to z minus a complex number. So according to z minus 2i, right? If I want to put it into a complex number form, it should be z minus bracket 0 plus 2i. So that when you substitute the negative inside, you will have negative 2i here. Okay, then for the second part here, this one, right? So to make it as z minus a complex number pattern, it should be negative 2 plus I. So you can see that it is z minus complex number negative 2 plus I. Okay, then when we are having both sides with inequality, in a complex number inequality, right? Basically, this is a perpendicular bisector between the 2 points. So maybe we need to do a little bit of drawing. Make sure that the x ratio, the ratio for the x-axis and also the ratio for the y-axis are the same and should be the same, right? And then should be try to draw it as accurate as possible so that your graph doesn't look very weird. Alright, then let me label it first. Okay, then first of all, we are going to sketch the point or plot the point 0 plus 2i. So where is 0 plus 2i? 0 is x equals to 0 plus 2i means y equals to 2. The imaginary axis equals to 2. So this is the point I have for 0 plus 2i. After that, I need to sketch negative 2 plus I. So negative 2 plus I means you need to plot the point negative 2 and 1. Okay, so these are the 2 points that we have, and they are asking us to draw a perpendicular bisector between these 2 points. To draw a perpendicular bisector between these 2 points, right? Okay, so try to imagine that this is the original line that I have. Where is the midpoint of these 2 points? So the midpoint will be somewhere here. Okay, so if your measurement is accurate, right? Then basically it should be at negative 1 and also 1.5. Okay, then after that, to draw a perpendicular bisector, you can use a ruler to help you or maybe some other tools to help you so they can draw roughly the perpendicular bisector that pass through the midpoint. Okay, so the perpendicular bisector should look something like this. Okay, so personally, I didn't go and measure or I didn't go and calculate what is the y-intercept. Okay, so just that by trying to use some tools to help me, right? I try to make the line as 90 degrees as possible, then I just draw it straight away. So personally, I didn't go and do any calculation about the y-intercept. Okay, then I will try to label this as a 90 degree so that the examiner know that this line is a 90-degree line, perpendicular line. And if I draw this one, that means it is a perpendicular bisector line between these 2 points. Okay, so this is my first inequality. My first equation, okay, that involve the complex number z with modulus both sides. And now for the inequality part, I need to shade the area, right? So which is the area that I should shade? Okay, when I'm having z minus 0 plus 2i smaller than z minus negative 2 plus I. So there are two areas that we need to consider. Either is this area, okay, on the right hand side of the line, or this area on the left hand side of the line. Okay, so just to let you know a little bit about the meaning of this inequality, right? When we are having modulus z minus 0 plus 2i, it means that the distance, modulus means distance. Okay, the modulus means distance. So this left hand side modulus here means that it is actually the distance between the locus z and the point 0, 2. Okay, then this one also have modulus, right? So modulus means the distance. Okay, so they are talking about the distance between z and also the point negative 2 and 1. After that, they are asking for smaller than. So if you try to interpret it by using some simple sentence, right, from the meaning of the question, they are asking for the area where distance from z to 0, 2 will be smaller than distance from z to negative 2 and 1. Okay, so now what is the z? Z means this one, this line. Any point on this line basically is the z. Okay, then if my z is in this point, this one, can you see the highlight point? It's at the midpoint. If let's say my z is here, that means the distance from z to 0, 2 will be equals to the distance from z to negative 2 and 1. So this is the midpoint. Midpoint means the distance are equal, right? But if I'm interested for the distance z to 0, 2 is smaller than z to 2, 1, that means your z should move closer to 0, 2, which means that I'm interested for this area. So when I want to shade the area, I should shade this whole area here. Alright, so this is how we decide which is the area to be shaded when you want to draw or shade the area when the complex number z satisfy the inequality. Okay, alright, so that's the meaning now. So if let's say you understand the meaning, it will be easier for you to decide which is the area to be shaded, right? Okay, now so this is my first inequality, and now I'm having the second inequality. So again, the same thing happened here. I'm having 0, and then argument z minus a complex number smaller equals to pi over 4. So what's the complex number here that I should write? So I will have negative 1 plus 0i. So that when you substitute the 0 inside, you are still having negative 1. So I write nicer here. Okay? Right, so how am I going to sketch this second inequality here? So first of all, I try to plot negative 1 and 0. So where's the negative 1 and 0? It should be this point. Alright, then negative 1 and 0, when the argument, okay, from this point is 0, means that on the right hand side, you draw a horizontal line. So this one means that basically the argument is 0, horizontal, right? And after that, to sketch the inequality or maybe the equation for the argument equals to pi over 4. So pi over 4 is 45 degrees, which means that from the right hand side of the point, you need to measure to get pi over 4, 45 degrees, and you draw a line up. Okay, so if I enlarge it, so this blue color part here will be actually pi over 4, which is 45 degrees. And by using a little bit of knowledge on the ratio of the triangle, right? Tangent pi over 4 should be 1, which means that the bottom, okay, for the triangle here, right? There's a small triangle here. I hope that you can see that. For the small triangle here, the base is 1 unit. Therefore, the height should be also 1 unit, so that tangent inverse equals to tangent pi over 4 equals to 1. So by right, your line here should pass through the point 0, 1. Okay, so this is the small details that I think you need to show when you're drawing the line. Okay, all right, so this is the blue color part, which is the second inequality. So for this second inequality, where should I shade the area? So they are saying that they want to shade the area where it is between 0 until pi over 4. So 0 is a horizontal line, pi over 4 is this slope line here. So the area between these two parts will be this one. So this is the area for the second inequality. Okay, so if I want to shape the area that fulfill these two inequality, so we are looking for the intersection part of the yellow and also the blue color. So the intersection part of the yellow or the blue color will be something here. All right. Okay, so if I try to draw the overlapping part of this, then it will look something like this. Then I'm so sorry that my graph looks a little bit too small. Okay, a little bit too small. So I might need to enlarge it later. Okay, wait, yeah. So let's say this is the 1. So you pass through the 1. And this area is, this angle is pi over 4. Okay, so finally, if I want to shade the area that I'm going to consider, right, it is actually the overlapping between the yellow just now and also the blue color part. So my shaded area should be this one. Okay, then please take note that if let's say your scale is bigger, right, by right, there's a small area here is not shaded. Can you see that? This one, the small area here is not shaded. All right. Okay, so this is how we decide how to shape the area that fulfill the two inequality in the complex number. So question number 3. We are given a diagram and then the variable x and y are related by the equation, this one, y equals to ab power x, sorry. Then a and b are constant. The diagram shows the result by plotting ln y against x. Alright, so you realize that our y axis will be the ln y, not the original y. Okay, so for the two pair of values of x and y, the coordinates of these points are these two. So by using this information, find the values of A and also the B. Okay, so for this question, right, because the diagram that we sketch is by using ln y over x, ln y against x. Therefore, to use the information in the diagram to solve for the equation, right, you need to try and change our original equation become something with ln y. If not, then I'm not able to use the information from the diagram to continue and solve for the A and B. Okay, so for original equation, this is what we have lah. All right, then to change it become ln y, maybe I can consider to take ln for the both sides. So I'm having ln y equals to ln bracket ab power x. So by using a little bit of the properties in the logarithmic function, right? So ln a plus a times bx, you can actually separate become ln a, then plus ln b power x. Then if you further continue to simplify, the power in the ln can take it in front as a constant. So I'm having y ln y equals to ln a plus x ln b. So from here you can see very clearly that ln y is actually my y-axis and also x is the x-axis. So which means at this stage, I'm able to use the information and the plot and the point from the diagram and substitute into the equation that we formed here. Alright, okay, so now in this question they are saying that these 2 points are the passing point. Basically you should know that the value of x is the 1 and the value of 3.7 from this diagram, it actually means ln y. So I want to substitute the first point here into my equation. If I substitute the first point into my equation, ln y will be equals to 3.7. Okay, that equals to ln a. I don't know what's the value. I want to find out. What's the value of x? It is a 1. So you're having ln a plus ln b. And this will be my very first equation. Then for the second equation, I'm using the second point here. So 2.2 again is the value of x. And 6.46 will be the value of ln y. If I substitute back into my equation, so ln y equals to 6.46 equals to ln a, then plus ln b. So x ln b, x is what? X is 2.2 for this case, and then ln b. And this will be my second equation. Alright, okay. Then after that, you just need to try and solve the simultaneous equation to get the answer. So for me, I'm using equation number 2 minus equation number 1. If I take 2 minus 1, then I'm having 6.46, okay, minus 3.7. Then you get 2.76. Then equals to ln a minus ln a becomes 0. 2.2 minus 1. You're having 1.2 ln b. Okay, so from here, I'll get ln b equals to a value 2.3. And after that, to get the b, you need to bring the ln over, right? So you bring the ln over, it is actually the base e. So you're having e power 2.3. So your b is a long answer. But of course, I will correct it to 3 significant figure, where b can be equals to 9.97. But of course, this answer is already a answer that we simplify it to 3 significant figure. Okay, but this is the answer for the b. Alright, and after that, I want to get the value for a. So how am I going to get the value for a here? Okay, then again, substitute the answer, the value for part b into either one of the equation here. So for me, I will substitute into equation number 1, where I will have 3.7 equals to ln a plus ln b. So I'm having ln e power 2.3 because e power 2.3 is my b. Okay, I will strongly suggest you to substitute b by using e power 2.3 but not 9.97 because 9.97 is the answer that we have actually simplified them. Alright, or correct it to 3 significant figure. So by right, for any substitution to solve the solution, you should try to use back the original value that we have, which is e power 2.3. Okay, then ln e power 2.3 should give you the value 2.3. Okay, if you try to press calculator also, it will give you this value. And after that, what is the a? Ln a. So ln a equals to 1.4. Then a equals to e power 1.4. And again, I will correct my answer to 3 significant figure. Then the value of a should be 4.06. Alright, so basically this is how we solve the question number 3. Alright, so question number 4, there's a complex number u defined by this, and then a is a real number. So they want us to express u in the Cartesian form of x plus iy, then x and y are in terms of a. Okay, then basically to change our complex number become x plus yi, right? The process we call it as generalization of the denominator, yeah. So to generalize the denominator, what I'm going to do is like I need to multiply what I have as a denominator, but I change the sign for the imaginary part. So I want to multiply with a plus 5i. So for the top also, I try to multiply with a plus 5i so that actually the equation are still balanced, right? Then just try to do a little bit of expansion and simplify it, then you'll get the answer. So a times a, so you have to do the multiplication between the two brackets. Alright, so a times a is a square. Then you expand negative 5ai plus 5ai, you cancel off each other. Then negative 5i plus positive 5i will have negative 25i squared. Okay, then for the top, if you try to expand the two brackets here, so by right you will have 3a, then plus 15i, then plus 2ai, then plus 10i squared. Okay, then further simplify them. Okay, so to further simplify them, right, I just want to do a little bit of reminder here. What is the I squared? Actually, we cannot express we need to simplify the I squared or any power of I. in our complex number part. So I square, you should know that it should be equals to -1. Okay, so from here you can see that I'm having an I square here. I'm having another I square here. So change the I square become -1 and you simplify your answer. So by right you should have 3a minus 10 then plus 2a plus 15i divided by a squared plus 25. So if I want to put it into the x plus iy form, then my xi will be 3a minus 10 divided by a squared plus 15. This, oh sorry, 25. This is the real part lah. Then plus the imaginary part where it should be 2a plus 15 divided by a squared plus 25. Okay, so if you didn't do any careless mistake, by right, this is something that you should get. So this is how we actually rationalize our complex number to make it into the x plus or yi form. Okay, so part A. Then let's continue to part number B. Okay, for part number B, they are saying that argument u equals to pi over 4. So find the value of A. Okay, so to find the argument, we know that pi over 4 is in the first quadrant. So for this question, by right, it should be, to find the argument u, it should be tangent inverse y over x. Okay, then now I have to use my rationalized answer, okay, in the first part to solve for the b. Okay, so tangent inverse y over x. Y is this one. X is this one, right? So if I write tangent inverse y over x, it will be equals to 2a plus 15 divided by a squared plus 25. This is the y. Okay, then divided by x. So what is the x? The x will be 3a minus 10 over a squared plus 25. Okay, so this is how we find out the argument, tangent inverse y over x. And I know that tangent inverse y over x, the argument is equals to pi over 4. Okay, then next step, I try to simplify the fraction in this tangent inverse. I will have 2a plus 15 divided by 3a minus 10 equals to, I bring the tangent inverse over, it will become tangent pi over 4. Yeah, so I think from here, the question become very, very easy because you just need to try to solve this equation here. Okay, so tangent pi over 4 is a 1. So you're having 2a plus 15 equals to 3a minus 10. And if you try to solve it, you will get a equals to 25. Okay, so this is how we get the answer for question number 4. Right, so let's discuss question number 5. They give us this equation and they want us to find the exact value for tangent x. Alright, so to get the tangent x, I need to have sine over cos. Okay, then in our equation here, I need to expand everything so that I can have something with sine x and also I have something with cos x. Right, so to expand every single term in this equation, we can use the compound angle formula to expand them. So it is provided in the formula booklet and I try to copy it over here. So the formula booklet is inside this part, Right, so sine A plus B, you can have sine A cos B plus cos A sine B. So same thing happen for every single term at this part. So now I'm having this one, sine A plus B. So I should have sine A cos B. So you write out sine A cos B. So sine X cos pi over 6. Then plus, it is a plus, right? So you follow the plus sign here. Then cos A sine B. So it will become cos X. Then sine pi over 6. So this is the first term. Okay, then for the second term, you have to minus sine A minus B. So you take a minus, don't forget about the brick bracket, and then you expand it by using compound angle formula. So sine A minus B. You will have sine A cos B again. So sine A cos B, then minus cos A sine B. So cos X sine pi over 6, then close bracket. So that's the second term. Okay, then equals to the first term on the right hand side is cos X plus pi over 3. So I'm looking at cos A plus B. If you expand them, then basically you're having cos A cos B. Okay, then minus sine A sine B. So minus sine A sine B. Okay, then the last term that we are having is this one, cos A minus B. So you need to put a minus sign here. Therefore, I put a minus sign with a big bracket. Okay, so cos A minus B will give me cos A cos B. So cos X cos pi over 3 plus, inside is minus, then outside is plus, right? So sine A sine B. So you're having sine X sine pi over 3. Okay, so you can see that after you expand, it is very long. Okay, so let's have a look here. So this is the steps. Okay, this is the step that you have after you expand them. Okay, so after you expand them, to make everything become sine over sine and cos. So what we need to do is that we have to substitute all the value that we know. So as an example, what's the value for pi over 6? So for pi over 6, you're having square root 3 over 2. So become square root 3 over 2 sine x. Okay, then for this second term here, sine pi over 6 will give you a half. So half, then cos x. If you're not so sure how to get the value, you can press calculator to help you. That's the first thing. And if you are using MS calculator, then you might need to use a triangle to help you, where the ratio of the triangle is very important that you need to remember, especially for those who are using MS calculator to get the third form, right? So if I say you're having 30 degree, which is pi over 6, opposite will be 1, then the hypotenuse will be a 2, and this will be square root 3. So this one will be pi over 3. Okay, so for cos pi over 6, this is the how you get the value from the triangle if you are not using an ES calculator. Okay, so let's continue. Then for the next one, minus, I copy the minus. So what's the value for cos pi over 6? Again, cos pi over 6 will give you square root 3 over 2. Then sine x. So negative multiply with negative, we get a plus, right? Okay, so what's the value for sine 30 degrees? Sine pi over 6 will give you half. So half cos x. Okay, and actually if this part, if you have a look for the left hand side, right, these two terms can be simplified. Okay, then continue further to the right hand side. Okay, what's the value for cos pi over 3? So cos pi over 3 give you half. So half cos x minus sine pi over 3 give you sine 3 over 2. Then sine x. Okay, then minus again. Cos pi over 3 also give you half. Then cos x. Then negative, multiply inside, you have negative. Sine pi over 3 give you sine 3 over 2. Then sine x. Again, if you try to observe, right, basically you will have half cos x minus half of cos x become 0. Okay, then continue to simplify the term on the left hand side. So I'm having this one, half cos x plus half cos x become 1. So I'm having 1 cos x equals to negative sine 3 over 2, negative sine 3 over 2. So you're having negative sine 3 sine x. Okay, then after that, they want you to find out the answer for exact value for the tangent, right? So to get the tangent, you need to bring the cos over. Okay, become divide. So you're having sine x divided by cos. Then when you bring the cos over, right, you still have a 1 here. So for me, I want to bring the negative sine 3 over become negative sine 3 at the denominator. So if I simplify the answer, I will have tangent x equals to negative 1 over sine 3. So I will keep it in this form so that it is actually the exact value. Alright, so if you want to rationalize the denominator, the answer also can be negative sine 3 over 3. And both of them are the same. Right, so for this first question, we try to use the compound integral formula to expand the equation and simplify them. Alright, so this is how we solve question number 5, part A. So let's continue to part number B. For part B, they want us to solve this particular equation. So what they want is to find the exact roots. Highlight the keyword exact roots. That means the final answer cannot be in decimal number. It should be in surd form or maybe in pi form. Right, so if you try to observe this equation, right, basically this is what we have in the part A. And just now we have proved that this equation can be written as tangent x equals to negative surd 3 over 3. So to solve for this equation, you can directly solve it from here. All right, so first I want to get the basic angle first. So to get the basic angle, I want to have tangent inverse surd 3 over 3. Okay, so if you didn't do any careless mistake, if by right, it should be pi over 6. And now I want to get the value for x. Okay, so to get the value of x, still remember you need to go through the quadrant and we look for the quadrant that we want. So for the first quadrant, right, the answer is always theta, which is a basic angle, and everything is positive. Second quadrant, only sine is positive, and to get the answer, you have to take pi minus the basic angle. Third quadrant, only tangent is positive. Then to get the answer from this pi, you have to take tangent plus basic angle. And after that, for the fourth quadrant, cos is positive. To get the answer from here, you have to take 2 pi minus basic angle. Right, so for this question, we are looking for tangent x equals to a negative value. So in what quadrant tangent x is negative value? So second quadrant, tangent x will give you a negative value, right? So I want to accept the answer from here. So to get the answer from this quadrant, you have to take pi minus the basic angle. So the basic angle that we get just now is pi over 6. So that means you take pi minus pi over 6 and you get 5 pi over 6. All right, so second quadrant tangent is negative. Then in which quadrant else tangent is negative? So you can observe and see that, okay, in fourth quadrant, tangent is also negative. So to get answer from this pi, you have to take 2 pi minus the basic angle. So you take 2 pi minus pi over 6. When you take 2 pi minus pi over 6, you'll get 11 pi over 6. So this is how we get the exact roots for this particular equation. So this is how we solve question number. Okay, so now question number 6. We are given the parametric equation like this. Then they want us to obtain a simplified expression for dy dx in terms of t. Okay, so when you're having the parametric equation, to get the dy dx, right, you have to differentiate the equation separately, okay, from the parametric equation. So x equals to t power half plus 3. Okay, so let's find out the dx dt first. Right, so differentiate t power half, you put the power in front, copy the t, power minus 1 become negative half. Differentiate a constant 3, you get a 0. Then for the y, okay, y equals to ln t. So first we try to get dy over dt first. So dy dt, it is actually 1 over t lah. When you differentiate ln t, you should have 1 over t. Okay, then for the question, they want us to find out dy over dx. So to find out the dy over dx, basically what you need to do is we have to take dy over something, multiply with something over dt. So if you try to observe our steps here, right, our solution here, you already have dy dt and dx dt. So I can use dt here. So dy over dt multiply with dt over dx. What is dy over dt? 1 over t. What is dt over dx? It is actually the opposite of dx over dt. That means upside down. You have to change numerator become denominator. Denominator become numerator. So if you change it in that way, basically you're having 2 surd t. Okay, then of course you can simplify them. So surd t over t, you will have 2 over surd t. So 2 over surd t. So this is my dy dx. Okay, if you don't want to write in this form where you are having the surd form in the denominator, then you can just write into the power form. So power negative half. All right, so this is what we have for part A. Then let's continue to part number B. For part B, they want us to find the exact coordinate, highlight the keyword exact. Okay, exact coordinate of the point on the curve where the gradient of the normal is negative 2. All right, so gradient of the normal, they give us a value negative 2. So let's have a look how to connect the gradient of normal with gradient of tangent. So you should know that normal is perpendicular to tangent, right? So when you multiply the gradient together, it should be equals to -1. Because they are 90 degrees to each other, are perpendicular to each other. So I know that the gradient of normal is -2. Okay, but what is the gradient of tangent? So gradient of tangent actually is the dy dx from the curve, and it is equals to -1. So from here, you'll get a very useful information where the dy dx is equals to half. Okay, then if your dy dx equals to half, how can you get the coordinate? Coordinate means x and also the y. Okay, so to get the coordinate x and y, you substitute dy dx first into your equation here. So your dy dx just now, what you get is 2 over square root t, right? So you try to get 2 over square root t equals to half, and therefore your square root of t equals to 4. Then from there, you'll get t equals to 16. Alright, so from here you get the value of t, but of course for the question they're asking for x and y, so how are you going to get the value for x and y? So you have to substitute the value of t, go back into the parametric equation. So substitute t here, you get an x, substitute t here, you get a y. Right? Okay, so quite straightforward. Okay, so what is the x? X will be square root 16, then plus 3. So by right, you should get 7. And to get the y, it is actually ln 16. Alright, so they want you to keep the coordinate in exact coordinates. So by right, my answer is 7 and also ln 16. Okay, so this is how we get the coordinate when your equation, gradient of the normal is equals to -2. So we try to link it with the gradient of tangent where it is equals to dy dx. Right, so this is how we solve question number 6. Okay, so question number 7, we are given a differential equation in terms of x and theta. This is what we have. Then we also been given the initial value. Okay, so they want us to solve the differential equation, obtaining expression for x squared in terms of theta. Okay, so to solve differential equation in our syllabus, right? Basically, you can separate the variable clearly. So I want to group all the x at one side, all the theta at the other side. Okay, so what I'm going to do now is I'm trying to move the x squared over 3, x squared plus 3 become the denominator here. And I will want to bring out tangent theta and also the d theta to the right hand side. So if I try to move them in this way, right? So basically what I having here is I'm having x over x squared plus 3 equals to tangent theta d theta. Okay, so from here you can see very clearly that I have successfully separated all my variable to two different sides. So all the x are at left hand side, all the theta are at right hand side. Okay, after I separate them clearly, then I can start my integration. Okay, so for this integration, you need to observe and see what patterns or what formula can you apply to find out the answer for the integration here. Okay, so I'm having x over x squared plus 3. It is a fraction, which means that if I try to let function fx equal to the denominator, then basically, if I differentiate them, I should have 2x. Okay, so when I try to link it with the f prime x over fx pattern. So on top should be f prime x. So f prime x should be 2x, but now my numerator only have an x, which means that I can make this pattern become f prime x over fx pattern by multiplying a 2 inside the numerator. But if I multiply a 2 inside the numerator, I have to divide a 2 outside the whole thing so that the equation are still balanced, the terms are still balanced. I didn't change the question. Okay. Alright, then the purpose that I want to multiply a 2 inside is because of I want to have exactly f prime x over fx pattern for the integration. Okay, then same thing happened here for tangent. So you should know that tangent theta can be written as sine over cos. It is still a fraction, which means that if I try to let function fx again become the denominator, which is cos theta, then what is my f prime x here? So differentiate cos, you should have negative sign. Okay, if I look at my numerator, I already have sine theta on top, but lack of a negative. So to make it become f prime x of fx pattern, I multiply it a negative at the sine theta. Outside, I also want to multiply another negative. So that negative multiply negative become positive 1, which is the equation still balanced. I didn't change the final value of the equation. Okay, so when I already have both pattern with f prime x over fx pattern, then I can apply a specific formula for integration. Okay, so I think it's also provided in the formula booklet. You can have a look here. Oh, sorry, I don't think that it is provided, yeah. Wait, let me have a look. This one, yes, it is provided. So you can have a look here. When you want to integrate f prime x over fx pattern, generally you are having log fx. That means you bring the denominator up, okay, inside a log. So you're having log modulus fx. Same thing happen for what we have here. Okay, so for this pattern, you can see that 2x is f prime x, fx is x squared plus 3. So to integrate them, the constant half I just copied, all right, I didn't touch them. So integrate f prime x over fx pattern inside, okay, inside the fraction or inside the integration, you have ln fx. So ln fx, which is x squared plus 3. Then equals to, for tangent, okay, now I'm having negative sine theta over cos theta, which is also f prime x over fx pattern. So to integrate f prime x over fx pattern, you're having negative, copy the negative outside, then ln fx. So what's my fx here? Cos theta. So I successfully integrate the whole equation here. I need to put a plus c, a constant term at the back, and to find out the value later. Okay, so continue further. After the integration, the next thing is we are going to find out the value for constant. So how to find the value of constant? Look for the initial value that they give us in the question. So they are telling us that when x equals to 1, theta equals to 0. So given x equals to 1, theta equals to 0. Substitute the value inside the equation that we have, the solution that we have. So we are having 1 plus 3, which is a 4, equals to negative ln cos 0 is a 1, then plus c. Okay, so again, ln 1 is a 0. Therefore, from here, you can get c equals to half ln 4. Half ln 4 basically also means that ln 4 power half, which is equals to ln 2. Okay, so you get the value of c, which is ln 2 already. Then please rewrite your equation again. So I'm having half ln x squared plus 3 equals to negative ln cos theta, then plus ln 2. Okay, so the request of this question, right, is to express our answer in terms of x squared in terms of theta. So how to get x squared in terms of theta? There are many different ways that you can rephrase your expression here or your equation here. Okay, so first of all, I try to combine the ln on the right hand side. Okay, I'm using this result, the property of the ln function, where if I have ln A over B, then I will have ln A minus ln B. And now I'm going to do it backward. So backward means that if I'm having ln A minus ln B, then I want to do it backward, combine them, become ln A over B, which is also something that we can apply on the right hand side. So I'm having ln 2 minus ln cos theta, so it will become ln 2 over cos theta. Okay, then I don't like the 2 here, the half here, right? So if I don't like the half here, I will multiply the whole equation with the half. When I multiply the whole equation with the half, so left hand side I'm having ln x squared plus 3. Then for the right hand side I'm having 2 ln 2 over cos theta. Okay, the 2 here, you can bring it back, become the power, but the power is for the whole thing, okay, inside the ln. The whole expression in the ln must have a power 2. So again, I'm having ln x squared plus 3 equals to ln 2 squared, you get a 4. Then after that, you're having cos squared theta. Okay, so when you get under this step, right? So basically, both ln can be cancelled out lah, because we have one ln on the left, one ln on the right. Okay, with one term, so you can cancel out directly. And from here, you have x squared plus 3 equals to 4 over cos square theta. I can write it become 4 secant square theta. And further bring it over the 3, I'm having 4 secant square theta minus 3. So this is how I express my answer for x squared in terms of theta. Okay, so this is how we solve question number 7. Alright, so question number 8 now. By sketching a suitable pair of graphs, so I highlight the keyword pair. So pair means that you have to draw two graphs, okay, to show that this equation has only one root. So how to draw two graphs from this equation? So by right, you should know that the two equations here should be y equals to square root x. Then the other one you have to sketch is y equals to e power x minus 3. Okay, so y equals to square root x, it is quite easy to sketch. So by right, it should be something like this. Okay, right, then this is y equals to square root x. Then now for the other equation that we need to draw is e power x minus 3. Okay, so maybe you can try to imagine first the original graph for e. Original graph for e, right? X equals to 0 is the asymptote. Sorry, y equals to 0 is the asymptote. So the graph will get closer and closer to the x-axis and x equals to negative infinity, but it will not touch the x-axis. Then it will always pass through the 1 at the y as the y-intercept. If I want to have a x e power x minus 3, right? So minus 3 means that you minus the 3 outside the basic function, which also means that you have to move the graph 3 units downward. When you move it 3 units downward, originally this line is y equals to 0. So bring it 3 units downward means that you're having y equals to negative 3 now. Okay, so now you're having a asymptote at the line y equals to negative 3. And after that, you are going to sketch the diagram here, right? From here, from negative 3 going up and pass through the 1. Y-intercept is the 1. If you move down the 1 to 3 units, so basically you are having negative 2. So now your y-intercept will become negative 2. Okay, so if you try to sketch a diagram, basically your diagram should look something like this. The shape of the graph stays the same, yeah? Okay, you didn't change the shape of the graph, but we are moving the whole graph 3 units down again. So this is actually y equals to e power x minus 3. Okay, then how are we going to show that the equation has only one root? So after you sketch a two graph here, let's observe and see how many intersection points do we have between the two graphs. So there's only one intersection point, right? So you have to make a simple conclusion where one intersection point can be seen. Okay, so therefore there's only one root. The equation has only one root. Okay, so when you sketch the diagram, please make sure that you label the graph very clearly, right? Okay, then proceed to next part. Part number B. So show by calculation that the root lies between 1 and 2. So to show the roots lies between any two value given, we have to use the sign change method. So for the sign change method, I will get it from the original equation. This is the original equation that I have, right? E power x minus 3 equals to square root x. So I want to bring my equation, everything to one side. So I will have fx equals to, I try to bring the negative 3 and e power x over. So when you bring the e power x over, it becomes negative e power x. Right. Then 3, when you bring it over, it becomes positive 3. Yeah, then after that, I try to substitute the value 1 and also the 2 into the equation, into the expression. So when you substitute x equals to 1, that means you're having square root 1 minus e power 1, then plus 3. So you get one value. If you didn't do any careless mistake, by right, it should be 1.28. Then now you substitute x equals to 2. Okay, then again, if you didn't do any canon mistake, by right, you should have 2.97. All right. Okay, so there's another option. If let's say some students, they are changing the equation in the opposite direction, where they are having x e power x minus 3, then minus third 3, or third x, sorry. If we are moving the third x to the other side, then basically the answer is also the same, only the change, the sign is different. So this one will be negative 1.28, this one is 2.97. So just want to let you know that actually both are correct, all right? Okay, then you can see the sign change, right? One is positive value, one is negative. So you can make a simple conclusion. So sign change can be seen between the F1 and also F2. Okay, so this also means that the root lies between the value 1 and also 2. Okay, yeah, so this is how we show it. All right, then next part, question number 3. Okay, so for question number 3, they want us to show that if the sequence of the value given by the iteration formula converge, then it converges to the root in the first equation. All right, so generally, to get the answer, what you need to do is like you can prove this one, this iterative formula, to get back the original equation. Original equation is square root x equals to e power x minus 3. Or you can do it the other way around, start from the original equation and get the iterative formula. So either one direction also you can prove. Okay, so for me, I will start from original equation. I just want to show that this original equation can give me this iterative formula. Okay, so let's start. I will group square root x and 3 together become square root x plus 3, because in my solution here I can see square root x plus 3. Then when I take ln both sides, then answer is out. So it's a very simple proving. Okay. Okay, so you can see that the iteration formula can be get from the original equation provided in part A. Then next one, we will continue to the part number D. Okay, now they want us to use the iterative formula to calculate the root. Root correct to 2 decimal places. Then the result of each iteration is 4 decimal places. Okay, so let's start. The iterative formula given is x n plus 1 equals to ln 3 plus xn. Okay, so first of all, we need to have an initial value. Alright, so what's the initial value that we can use? We can always refer to the sign change method value to start or to decide the initial value. Because from the sign change method, right, we already know that our root is more or less between 1 and 2. So use a value that's close to the root so that you can get the final answer for the root easier or faster. So maybe for me, I will want to use 1.5. Alright. If you want to use 1 also no problem. You want to use 2 also no problem. Okay. How can I get x2? To get the x2, basically I'm substituting the 1.5 into my iteration formula, into the right hand side of the iterative formula. So I'm having ln 3 plus square root 1.5. Then I get the value. Okay, so this value I have to put it in 4 decimal places because it is iteration. Okay, so for me personally, I will always use a calculator to help me. So what I'm going to do now is I'm trying to type in, okay, or key in the formula for ln 3 plus square root x. So key in the formula ln 3 plus square root x, right? So you put a 3 then plus square root x. The x can be get by using alpha close bracket. Okay, then after that I'm closing my bracket here. So this is my iterative formula, right? Okay, then to substitute, to get the x2, you have to substitute 1.5. So press calculate, then press 1.5. and press equal sign. Then from here in the calculator, you get this number 1.4409588876 is a long value. So they did instruct or give us an instruction where our iteration should be in 4 decimal places. So the 4 decimal places answer from this part will be 1.4410. So this value will be 1.4410. Then to get the next one, x3. Okay, so to get the x3, again, go back to your calculator, press calculate, and they're asking you to input your value of x. And now my value of x will be 1.4410. So I key in 1.4410, then press equal sign. And this is the next value that I get for x3, which is 1.4352. So 1.4352. Okay, so I want to continue further to get x4. So same steps apply. Try to press calculate in calculator, key the value that we have to substitute, which is 1.4352 now. Then press the equal sign. We have 1.4346, 1.4346. Okay, so if some students are asking when should you stop or where should you stop, basically you can stop by checking the answer for 2 decimal places because your final answer for root is 2 decimal places, right? Yeah, so what you can do is you can have a try. So this one, 2 decimal places answer give you 1.44. This one, 2 decimal places answer also give you 1.44. This one, 2 decimal places answer also give you 1.44. So you can see that 1.44 has been repeated for 3 times. Usually if repeated twice, then you can stop already. But for me, usually I want it to be safe. I will actually try one more extra iteration. So I got 3 repeated value for 2 decimal places, which is 1.44. Then I will just write out the root equals to 1 point. Oh, sorry. There's a mistake, right? Okay, so I think I cannot conclude it yet. Sorry. The value here is 1.44. Then this one is 1.44 as well. Okay, but like what I mentioned earlier, usually for me, I will prefer to attempt more, a few more trials or a few more iterations to make sure that it is really repeated. Okay, so for this one, if I have a look for the 2 decimal number answer, it should be 1.43 only. So which means that it is not repeated yet, okay, not fixed yet, because these two give you 1.44 and then this one give you 1.33. 1.43, sorry. So I need to continue further and to confirm my answer. Okay, so to get x5, I press calculate again, then key in 1.4346, then press equal sign. So by right, you should have 1.4345, 1.4345. Okay, so this one is 1.43. Okay, then again, usually for 2 times repeated, I'm not feeling secure. I will just continue for one more extra one, just to double check, okay? Then 1.4345. So type in calculate, then key in 1.4345 and press equal sign. By right, you should have 1.4345 again. So seems like the 4 decimal place answer also repeated already. So that means this will be the very safe my final answer. So to show them the final answer, don't forget to write out the root equals to what? Equals to 1.43. Alright, so that's the reason why I usually will repeat a few more iteration, or I will try a few more iteration. It's just to avoid the condition like this. Okay, so like for this question, originally if let's say you are having for x2 and x3, right? By right, 2 decimal places are 1.44 and 1.44. But when you try to key in another iteration, you realize that it becomes 1.43. So to avoid all this situation, usually for me personally, I will actually key in more iteration. So usually I will look for maybe 3 repeated 2 decimal answer, then only I will conclude and stop that. That will be my root. Okay, all right. So this is how we solve question number 8. And let's look for question number 9 now. Okay, so let's have a look for question number 9. We are given the diagram and it shows the curve of this equation. for x greater equals to 0, and the maximum point is the m. So m is the maximum point. They want to find the exact coordinate of m. Highlight the keyword exact coordinate. Alright, so exact means that your answer later, right, must keep it in the surd form or pi form or maybe e, the form in e lah. Alright, it shouldn't be a long decimal number. Okay, so what do we have here is we are having this equation y equals to the multiplication of of x and also e power negative 1 over 4x squared. To find the maximum point, generally we need to find out dy dx, and we let dy dx equals to 0, because at the maximum point, the radian or tangent, okay, will be parallel to the x-axis, therefore it will be equals to 0. So we need to find the differentiation first, then you let it equals to 0 and find the x coordinate. Alright, so for this function, right, it is a multiplication for two functions here, x multiplied with e power something. So to find out the differentiation for this one, you actually have to use the product rule for differentiation. So what is the product rule? So you can see this is the product rule that we have. Differentiation should be here. Okay, so product rule is this one. U multiply with V is equals to V du dx plus U dv dx. Right. Okay, sorry. So let's continue further. Okay, then so for your information, you should know that okay, the x you can treat as a u, and then the e power negative 1 over 4x squared is a v. So to get the dy dx, the general formula that we see just now is differentiate, maybe copy the first bracket, differentiate the second, which is dv dx, then plus copy the second bracket, differentiate the first. So this is the general formula lah, when you want to apply product rule. Okay, to find the dy dx for the function. Alright, so we'll start. For me personally, I will not write out the detailed step like this. So what I remember is that I try to remember the process where I copy the first bracket. So my first bracket here is the x, so I copy the first bracket, differentiate the second. Differentiate e power negative 1 over 4x squared. You copy back the original thing. Then you differentiate the power. So differentiate the power, what do you have? You have negative 2 over 4x. Alright, so this is copy the first bracket, differentiate the second. Then now you do it the other way around. You copy the second bracket, differentiate the first. So differentiate x, what do we have? You have a 1. Okay, then from here we can try to simplify our equation. So I'm having e power negative 1 over 4x squared. I can factorize it out. And after that, I'm having negative half x squared, then plus 1. Okay, then after that, because we are finding out the maximum point, therefore we will let dy dx equals to 0. Okay, so that you can find out the coordinate of the maximum point, x coordinate for the maximum point. So there are two equations that you need to solve. The first one is 1 e power negative 1 over 4x squared equals to 0. And another equation is 1 minus half x squared equals to 0. Okay, then for this first equation here, if you try to take ln both sides and to get the value for x, right, ln 0 will give you a math error. Therefore, we are not able to get any solution from this part. So we are going to ignore this solution here, this equation. Then we can focus on the second equation here. So try to solve for the value of x. So we are having x squared equals to 2. And from that, you get x equals to, should be plus minus square root 2. When you take the square root by yourself. But of course, if you have a look for the question here or the diagram, they are already tell you very clearly that we only consider the x which is greater equals to 0. Alright, the m is on a positive x. Therefore, when you are trying to solve for the equation, you can ignore the negative sign. So my x is positive positive square root 2. And after that, if you look back to the question, they're asking for exact coordinates. Means that they want to have both x and y. So what's the y coordinate? Substitute the equation, substitute the value of x into the equation. So you're having square root 2 e power negative 1 over 4 square root 2 square, which is a 2. Okay, then if you try to simplify further again, so you're having square root 2 e power negative half. And further simplify again, e power negative half means also square root e, but it is at the denominator. So simplify that, you are having 2 over e. then the whole thing with square root. Therefore, the coordinate of m will give you the answer square root 2 and also square root 2 over e. Alright, so this is how we get the exact coordinate for the m. Okay, so to find the maximum point, basically you need to find out the dy dx, the differentiation, and you let it equals to 0. Okay, then let's continue to part number B. Okay, so for part number B, they want us to use the substitution x equals to square root u. So this is a keyword, a very obvious keyword already. So you have to apply integration by using substitution later. Alright, so find by the integration the exact area, highlight the keyword exact again, of the shaded region bounded by the curve, the x-axis, and also the line x equals to 3. Alright, so to find the area, of course, we need to use integration. Okay, to find the area under the graph lah. Okay, then to set up the question, first of all, you need to have a look for the diagram. So you can see that the area mainly bounded by the x-axis. Therefore, you have to use dx. Okay, then the area start from 0. So you're having lower limit 0. The area end at 3. So it is a 3 here, upper limit, and bounded by the curve. So this curve is having the equation xe power negative 1 over 4 x squared. So this is the generally this is the formula to find the area under the graph for this diagram. Okay, alright, so let's continue further from here. Okay, so just now we know that to set up the step, the value should be, the formula should be 0 until 3, then xe power negative 1 over 4 x squared. Right, so we actually not really able to integrate this directly, and they already give us a very clear keyword. So they ask you to use substitution x equals to sub u. So you have to use the substitution method. Okay, so substitution method, the step I will write here, yeah. So we will start with the substitution given x equals to square root u. So that means sub u. Okay, then you need to find out dx du first. So if you try to find out dx du, what you have here is you pull the power in front, copy the u power minus 1, become u power negative half. Then if you replace everything in terms x in terms of u, then you're having 1 over 2 square root u, then du. Okay, then besides this, you also need to try to find out the limit. So our limit, lower limit is a 3, lower limit is a 0, upper limit is a 3. So you let x equals to 0, try to find the u. So what will be the u here? So u basically will be x squared, which is 0 squared, and therefore you're having a 0. So just in case if you don't know why u equals to x squared, it is coming from the substitution equation here. X equals to square root u, therefore u equals to x squared. Then now the upper limit become a 3. So x equals to 3. What happened to my upper limit in terms of u? So the u value will become 3 squared, which is equals to a 9. Okay, then we will try to substitute all the information here into our equation. And we are trying to change all the x become u. Right, so let us start. Okay, so to change everything become u, the lower limit is still 0, upper limit 3 will become a 9. So we settle the limit part. Then now for the term inside the integration, we are having x. So what is the x? X equals to square root u. So you put it as a square root u. E, copy the e. Then negative 1 over 4 x squared. So you're having negative 1 over 4. X squared basically is a u. Because x equals to square root u, right? So u equals to x squared. Then how about the dx? So dx, just now you already know that we can change it, become this one. It will be 1 over 2 square root u du. Okay, so you can see that from the first line to the second line here, basically I have changed all the x, become everything in terms of u. Then before we can integrate it, of course we can try to simplify them first. So sub u and sub u can be cancelled off with each other. So from here, I can see that I have a constant half. So I prefer to take it out before I do the integration. Okay, then now it's quite easy for us to integrate e power negative 1 over 4u. So when you integrate this, you have the original e power negative 1 over 4u divide by the differentiation of the power. So when you differentiate the power of the e, you're having negative 1 over 4. So you're having negative 1 over 4. Then you need to put in the limit 9 and 0. Okay, so before I want to put in the value, I will want to simplify the value here first. So half divided by negative 1 over 4, you'll be having negative 2. After that, substitute 9 into my equation. I'm having negative 9 over 4 minus substitute 0 inside the equation. I'm having e power 0. Okay, then if you try to simplify the answer, you're having negative 2. Then e power negative 9 over 4 minus 1. E power 0 is a 1, right? Then further simplify them, you can multiply the 2 inside the bracket, expand it into the bracket. Then by right, you should have 2 minus 2e, then negative 9 over 4. So we'll keep our answer like this because they want us to have our exact area, right? So I will not change it become the log decimal number. I will just keep it in terms of e. Okay, so this is how we get the area for this diagram. Okay, so question number 10. We are given a function fx and then they want us to express fx in partial fractions. Alright, so let's have a look for our denominator first. So for my denominator, I'm having the x and also x squared. So when you multiply x with the x squared, you're having x power 3, right? So x power 3 means degree equals to 3. Okay, so this is the degree, or the denominator equals to 3. And then for the power on top, it is degree equals to 1. So degree on top, numerator is smaller than the degree at the bottom, which is the denominator. Therefore, this is a proper fraction. So for proper fraction, you can directly express them into the partial fraction without long division. Okay, then secondly, let's have a look for the factor that we have in denominator. This one is a linear factor. And for the second bracket here, we are having a square outside the bracket. So this is actually a repeated linear factor. So if I want to express them into partial fractions, the general pattern should look something like this. Yeah. Okay, so I'm having this first one is linear factor and also the repeated linear factor. So for linear factor, we're having a number 8 on top. So divided by 1 minus 2x. Then for repeated linear factor, we need to repeat it for twice, where the first time without the power 2 and the second time is with the power 2. Okay, then to simplify the equation and get the value for ABC, I need to make all the denominator disappear. So that means the whole equation here, I multiply it with 1 minus 2x and also 2 plus x squared. Okay, so for the whole equation, you multiply this. And of course, we can make all the denominator disappear in our equation. So I'm having 24x plus 13 equals to a. Cancel off the 1 minus 2x with 1 minus 2x. Therefore, a multiplied with 2 plus x squared. Then for the b, again, you're having 1 minus 2x and then multiply with 2 plus x. Then for c, you are having 1 minus 2x, which means that you try to multiply everything. Okay, multiply every single term with 1 minus 2x times 2 plus x squared. So after you simplify them, this is something that you should get. Okay, alright, then let's continue. If I want to get the value of a, b, and c, right, you can expand everything and compare the coefficient of x squared, x, or also the constant. So if you don't want to compare, what we can do is like we are trying to take the linear factor. So let's say I'm having the linear factor 2 plus x, linear factor 2 plus x here. So I will think a value to make this linear factor become 0. So I will let x equals to negative 2. If x equals to negative 2, this linear factor becomes 0. This one also becomes 0, right? This one becomes 0. This one also becomes 0. So let x equals to 2. Substitute x equals to negative 2. Sorry, x equals to negative 2 into every single term here with the x. So negative 2 times 24 plus 13. So it will give you a value negative 35. Substitute negative 2 here, the whole thing becomes 0. 0 times a is a 0. So substitute negative 2 here, the whole thing, this bracket becomes 0, multiply with the whole thing here also becomes 0. Substitute negative 2 here, you're having 5c. So very easily you can get the value for c, which is equals to negative 7. Okay, then let's have a look for the next linear factor. Okay, so just now I tried to make x plus 2 plus x become 0. Okay, then now I'm looking for the linear factor 1 minus 2x. So I'm having the 1 minus 2x here. What is the value that I should substitute so that this blue color linear factor become a 0? So by right, I should substitute half, x equals to half, so that this bracket will become 0. Again, substitute x equals to half into every single x in the equation. Okay, so substitute x equals to half, the left hand side here. By right, you should get the value 25. Substitute half into this part, so you're having 2 plus half. So 2 plus half, and you square it, you should get 25 over 4. And then you're having 25 over 4a. Okay, let's substitute half here. This bracket becomes 0, blue color bracket becomes 0, so the whole thing becomes 0 here. Substitute half here. Okay, this bracket becomes 0, 0 times c also a 0. So your equation becomes something very simple, which is 25 equals to 25 over 4a. Your a will be equals to 4. Alright, so you can see that we can get a and c very easily by using by letting the linear factor equals to 0. So you get the 2 value here. And after that, how can I get the value for b? So there's no more linear factor that you can use on the right hand side anymore, right? So for the last unknown, what you can do is that you can use any value that you never used before. So like for me, I will use x equals to 0. Okay, then substitute 0 into all the x here. So you're having 13 on the left hand side. Substitute 0 here, you're having 2 plus 0 square, so which is a 4. 4 times a, you get 16. Okay, so how you get 16? Because 4 times a already know it is a value 4, right? So 4 times 4, you get a 16 here. Then after that, what do I have for the second part here? Substitute 0, you're having 2b. Okay, so you just keep it as plus 2b. And now substitute 0 here, you're having a c. c is negative 7. So if you try to simplify your equation on this part, generally you are having b equals to 2. Okay, so this is how you successfully get all the value for a, b, and c. And then for my practice, I will strongly suggest you to rewrite your partial fraction in a complete form again. Okay, so this is what we have. So 1 minus 2x, 2 plus x squared can be expressed as 4 over 1 minus 2x, then plus 2 over 2 plus x, then minus 7 over 2 plus x squared. Okay, so this is how we get the partial fraction for this function. Okay, so let's continue further to part number b. Okay, so for part number b, they are asking us to obtain the expansion of fx in ascending power of x up to and including the term in x squared. Okay, so to make it become the ascending power of x, basically this is binomial expansion. And for the binomial expansion, right, I need the original answer first. So what's my original answer here? Original answer is, I just write the partial fraction, yeah. So 4 divided by 1 minus 2x, and then plus 2 over 2 plus x, and also negative 7 over 2 plus x squared. Okay, so this is my original partial fraction. So to find out the binomial expansion for the partial fraction, right, it will be slightly easier if you use the partial fraction instead of use the original rational function, because you need to multiply every single term, which is, to me, is more complicated and also easier to make careless mistake. So personally, I feel that using partial fraction to find the binomial expansion is slightly easier. Okay, at least you won't do careless mistakes so easily, right? So for binomial expansion formula, of course, you can still refer to the formula booklet. So this is what we have here. This one. So for A2 syllabus, this is what we have. Okay, you can try to remember it or memorize it. Okay, so maybe for me, what I can do is like I try to copy it over to our page. Okay, so wait a moment. This is a general formula for the binomial expansion that we are going to apply. Okay, so I will keep it here. Okay, so if you refer to this formula provided, right? Okay. Alright, so you need to aware that to apply this formula, the first term must start with 1. Okay? And then you must put your pattern, your equation in the pattern of 1 plus x, the whole bracket power n. Okay, so you have to reverse it in that way. So first step, what am I going to do now is I try to put my partial fraction into 1 plus x power n first. Okay, so for the first term, I'm having 4. If I bring up the bracket, I'm having 1 minus 2x power negative 1. Right? Because power 1 at the bottom, when you bring it up, it becomes power negative 1. Then for the second fraction, I'm having a 2. Then if I bring the bracket up, I'm having 2 plus x power negative 1 also. Then for the third bracket, I'm having a negative 7, right? So I just put it as negative 7. For the bracket that I want to bring it up, it will become 2 plus x power negative 2. Okay, so first of all, I try to bring up all the bracket first, become the negative power. Then, of course, for all this bracket, I can expand it by using binomial expansion formula. But for the second term and third term here, the second and the third bracket here, the first term of the bracket doesn't start with 1. So I need to do some adjustment to make it become 1. Okay, so what should I do now is, okay, for the original 2, I just copy as a 2. Then I want to take the 2 out from the bracket. So when I want to take the 2 out, it will become 2 power negative 1. So my bracket inside will become a 1. When you take the 2 out, right, the x will be affected as well. So you have x over 2. So that when you multiply the 2 inside back the bracket, you get back the x. Okay, then power negative 1 remain. For the third bracket, negative 7, I just copy. Again, I want to take out the 2, right? So when I want to take out the 2, I'm having 2 power negative 2. Then with the first term in the bracket become 1 because you take out the 2. It will also affect the value of x. When you take out the 2 from the x, then you need to have x over 2 in the bracket. Then power negative 2. Okay, again, next step. Before I try to expand everything by using the binomial expansion formula, I try to simplify all the terms here first. 2 multiply with 2 power negative 1, you get a 1. So you're having 1 plus x over 2 power negative 1. Then for this part, 2 power negative 2, you're having 1 over 4. So you're having 7 over 4 negative. Then 1 plus x over 2, then negative 2. Okay, so everything is adjusted nicely. Then you can apply and expand every single bracket here by using the binomial expansion formula. So they are interested up to x2, x squared, right? So we only focus on the first 3 terms here, this part of the formula, right? So you start, 4 is a constant, you copy as a 4. So 1, first term is always a 1 if you refer to the formula. Second term is nx, so nx means you take negative 1, which is the power n. X is the term at the back, so you're having negative 2x for this case. Then n and n minus 1, so you're having negative 1. My negative 1 become negative 2 divided by 2 factorial, then x squared. So your x is negative 2x and you square it. Okay, so this is my first bracket. After I expand until x squared, then I will stop. Okay, second term. Second bracket is 1 plus x over 2 power negative 1. Okay, so first term is 1. Second term is nx, so n is negative 1. X is x over 2. Third term. Excuse me. Then next one, third bracket. So copy negative 7 over 4. First term is an n. So first term is a 1. Second term is nx. So your n now is a negative 2. Power is negative 2, right? So your n equals to negative 2. X will be x over 2. Then for the third term is n minus 1. So negative 2 minus 1 become negative 3 divided by 2 factorial. Then x squared. So you're having the x and then you square it. Okay, so I hope that you can see very clearly that I try to separate them become by using different color of the pen. So I hope that you can see very clearly. So the red color one is this one, green color one after expand is this, then the blue color one is this. Okay. Then what should we do next is you have to simplify all the terms. So maybe you need some help from calculator. Slowly simplify all the terms here. For the red color one, right, you will have 4 plus 8x plus 16x squared if you try to multiply everything inside. Then for the green color one, if you simplify them, you should have 1, then minus half x, and also plus 1 over 4x squared. Then how about the blue color? So for the blue color, if you try to expand them, you're having negative 7 over 4, then plus 7 over 4x, and also minus 21 over 16x squared. Okay, then for the last step, of course, you can gather all the constant together, all the constant term together, all the x power 1 term together, and so on. So 4 plus 1 plus negative 4 over 7 over 4, you should have 13 over 4. Then for the term in x, so you are taking 8x minus half x, then plus 7 over 4x. Then if you didn't do any careless mistake, by right you're having 37 over 4. And for the last term, the x squared term, you should have 239 over 16 x squared. Okay, so if you expand it very carefully without any careless mistake, so by right, this is the first 3 terms up to x squared for your expansion for the function. Okay, alright, so let's continue further for part C. So for part C, they ask you to state the set of value x when the expansion is valid. Okay, so we go back to our expansion here. When we are talking about the valid value for expansion, right? Okay, so you need to have a look for every single bracket for the valid value of x, and also we need to choose the smallest one, okay, the smallest range with the smallest range. So for this one, basically you're having the modulus x really smaller than half. Then for the second bracket, it should be modulus x smaller than 2. Then this one also should be modulus x smaller than 2. So if you try to compare these three, right, which one is having the smallest range? So the smallest range should be this one, okay, because the range is from negative half until positive half. The 2 one is from negative 2 until positive 2. So if you compare these two range, the modulus x smaller than half will be the smaller range. Therefore, the valid value of x, okay, for the expansion value is modulus x smaller than half. Okay, so this is how we solve the question number 10. Okay, so now we are at the last question for this paper. Question number 11. You are given a diagram and then it is actually a cuboid like OA, B, C, D, E, F, G. Okay, then they tell you all the details here. OA is 3 units, OC is 2, and then OD is 2 units. And then they also give you the direction of IJK. Okay, so you can see the details from the diagram. Then M is the midpoint of the EF. Okay, so first question, they want us to find the position vector of M. So position vector, position means start from O. So you are looking for the vector OM. Start from the origin O, okay? So what is the OM here? So you can start from O. You can see that I'm having a starting point at O. So to get the OM, maybe the very first pathway I want to go through is this one, O to A first. So from O, go to A, it should be 3 units, right? They are telling you that OA equals to 3 units, so you're having 3i. Then from A, we are heading to E. So from A to E, it's in the J direction, and AE equals to OD. So OD is 2 units, therefore you're having 2J. After that, from E, you are going up to the M. So from E to M, right, it should be 1 unit because from O to C, from bottom to top is 2 units, but M is the midpoint. So from here is 1 unit and MF is 1 unit. So this is 1 unit. So for 1 unit is in the direction of K. So you're having 1K. So basically, this is the coordinate of OM that we have, or maybe the position vector of OM, of M, right? Okay, then after that, let's proceed to part number B. So for part number B, they are telling you that the position vector of P is 1J and IJ and 2K. Calculate the angle PAM. Alright, so before you want to calculate the angle PAM, right? Maybe we need to have a look at what's the angle that we have. So they are interested for us to find the angle P, A, and also M. So let's say this is the theta. To find out the angle by using vector, so you should have using the vector that both going out from the angle, okay, from one point, which is AP and AM. So if I want to form the formula by using the product rule, it should be AM dot AP equals to modulus AM modulus AP and then cos theta. This is the rules that we can use to find out the angle between two vectors. Right, so the vector that we are using is AM and also AP. Okay, so first, let us find out the vector AP first. So vector AP is AO plus OP. So what is AO? AO will be opposite of OA, so -3, then 0, 0. That is OA. And then plus OP. So OP, what is the value of OP? The position vector of OP, this one, right? 1, 1, 2. So 1, 1, 2. Okay, so from here, you get the vector AP, which is equals to -2, 1, and also 2. Okay, then next I want to get the vector AM. Again, AM means AO plus OM. So AO is -3, 0, 0. OM is the position vector of M. You already get it just now, which is 3, 2, and also 1. If you simplify this, then basically you're having 0, 2, 1. Alright, then after that, what am I going to do now is I try to apply everything here into the formula that I'm going to use. So AM dot AP. AM means 0, 2, 1. Dot product with AP. So -2, 1, and also 2. Okay, equals to modulus of AM. So what is the modulus of AM? You're having square root 0 square plus 2 square plus 1 square. Then the modulus of AP is -2 square plus 1 square plus 2 square with cos theta. Okay, simplify all the terms that we have here. So for dot product, what we do is like you try to multiply x with the x plus y with the y plus z with the z. So 0 times 2, you get a 0. 2 times 1, you get a 2. Then 1 times 2, you also get a 2. So you're having a 4 on the left equals to square root 9 and also square root 5 for cos theta. Okay, then to find the theta, it is very easy. You try to move everything to one side. So you're having 3 with square root 5. And therefore, your theta should be equals to cos inverse 4 over 3 square root 5. Okay, then you can get the answer 53.4 degrees. Of course, you can keep your answer in radian form if you want. So for radian form, of course, you need to make it into 3 significant figures. Alright, so for me, I prepared the answer in degree, so which is 53.4. Okay, right, then we have part C to go, so let's go for the part number C. Okay, so for part C, they want us to find the exact length, highlight the keyword exact, of the perpendicular from P to the line passing through O and M. Okay, so as an example, if let's say I want to draw in a simple way, right? I'm having a line. This is a line that pass through the O and also pass through the M. Then P is maybe somewhere here. And they actually want us to find out the perpendicular distance between the P and also the line OM. Okay, so to make the calculation easier, I will make this as F, point F. So the foot of perpendicular, I label it as point F. So that means for this question, I'm interested to find the distance for PF. Okay, so I'm interested to find the distance for PF. Alright, so to find out this length for PF, I will use the vector equation method to find it out. So first of all, I want to form the vector equation of the line OM. So what's the vector equation for line OM? The general equation is R equals to A plus TP, where A is the passing point, P is the direction of the line. For this question, okay, our passing point got two, okay? O is the passing point of the line, M is also the passing point of the line. So I'm using the O, which is easier. That means there you're having 0, 0, and 0. Plus TP. What's the direction of the line? So the direction of this line can be O to M or M to O. Okay, so if I use O to M, then basically the direction will be 3, 2, and also 1. Okay, Alright, so if I rewrite again, then basically I'm having T, then 3, 2, and also 1. Okay, so let's continue further. If I have the vector equation already, then let's find out the position vector of F. Okay, so you can see that F lies on the line OM. Therefore, the position vector of F is also equals to the line equation. Okay, so the position vector of F is OF. It is equals to T, then 1, 2, 3 also. It's like 3, 2, 1 also. Okay, alright, so this is a position vector of F. Alright, then maybe you will ask, why the position vector of F is equal to the line equation? It is because of when we are having a point, alright, on the line. When you substitute any value, some value of t, right, the coordinate you get is actually what sum of the point on the line. Alright, so therefore the position vector of F will be equals to the vector equation of the line itself. Okay. Then next step, we are going to find out PF. So I want to find PF because I know that at the very last step, I want to find the length of PF or the modulus of PF. So PF is needed. So how to find the PF? It is PO plus OF. So PO will become -1, -1, and also -2. Because your OP is 1, 1, 2, right? So PO is -1, -1, and -2. Then plus OF. So what is your OF here? So OF will be 3T, 2T, and also 1T. Group them together, you're having -1 plus 3T, -1 plus 2T, then -2 plus T. This is your PF. Okay, so next step. To find out the T in the PF here, I know that PF and also OM are perpendicular to each other, right? So they are 90 degrees to each other. So I'm going to use the result where PF dot OM, it will be equals to 0 because they are perpendicular to each other. So PF is -1 plus 3T, -1 plus 2T, -2 plus T. And I want to dot product with OM. So what's the OM direction? It should be 3, 2, and also 1. And we let it equals to 0. Okay, then I try to dot product these two vectors here. So if you didn't do any careless mistake, you should have -3 plus 90 minus 2 plus 4D, then minus 2 plus T. And it is equals to 0. Okay, simplify the equation and get the value of T from here. And therefore your T is equals to half. Okay, when your T is equals to half, substitute back into the PF vector, and thus you can get the vector for PF. So the vector of PF basically is half, 0, and also negative 3 over 2. Then to get the perpendicular distance between the P and also the line, right? So it is actually the length of the vector PF. So now I want to find out the length of the vector PF. So perpendicular distance between point P to line OM is actually equals to the modulus of PF. Okay, so we try to get the answer. So you're having modulus B, which is half square plus 0 square plus negative 3 over 2 square. Okay, so simplify them, you have square root 10 over 4. Then if you further simplify again, so square root 4 you get a half, right? So you get a 2, right? So you're having 1 over 2 with square root 10. So they're asking for exact distance, if I'm not mistaken. Let's have a look. Yeah, so they are looking for the exact length. Therefore, I will keep my answer in the third form, where it should be 10 over 2. Okay, so this is how we answer all the 11 questions for this paper, and thank you very much for watching the video.